review, very important when solving, when they appear inside parallel lines or transversal. You're like, oh, okay, I know something about that triangle, right? So scalene, so you have three types of triangles: scalene, isosceles, equilateral. Only isosceles and equilateral are what we call symmetric. Sorry, I was wrong. Symmetric. Symmetric. And what does the word symmetric mean? Grade 9 math, symmetry. What does that mean? Anybody remember symmetry? It means that when you can split something in half, right? There's a line where you can cut it and get two exact same halves, right? That's what symmetry is. And only these two are. There is a point where you can cut them and get exactly two halves, right? So this is asymmetric. You cannot cut it. All angles are different. All sides are different. Okay, so if you were to draw and label, we would have to say that this is different than this, and it's different than that. Right? All sides are different in length, even though it looks the same. Right? It looks like, oh yeah, these two sides look congruent. No, the markings tell us otherwise. So same with the angles. Right? This will be, there's a relationship between the side and the angle that we will explore as well. So this one is different than this one, which is different than this one. Right? So all angles are different, all sides are different. You cannot cut it in half. And isosceles, two congruent sides, two congruent angles. If you have one known angle, you can find the rest, basically. That's very important to understand, because, watch this here, right? If you have an isosceles triangle, you see these markings, focus on the angles that are across them. Okay? There's something we know about the angles that are across them that are also congruent. So if this is 72 on this side, we know, right? So this is the reasoning, guys. If these two sides are the same, then you look at the angle across one of them. Oh, that's 72. Therefore, this must be 72 as well. That's the reasoning behind it. Okay. And so now we know that angle Y up here, angle Y is going to be 180 minus 2 times 72. Or minus 72 minus 72, whatever works for you. And so we know that angle Y is 36 degrees. You know one, you know all of them, basically. You know one, you know all of them. Because, let's look at this next one. This is 50, right? And you're like, oh yeah, so therefore this is 50. No. Focus on these markings. And across this one, this is going to be the same as that. That's what we know. That is what we know. But they're the same, correct? They're the same? So I could just go to find angle F, which is the same thing as angle E, right? They're the same. I will just go like this, 180, subtract 50, right? I will subtract the one I know, and I'll split this in half. However, always, folks, when you have fractions and there's an operation happening either denominator or numerator, keep in mind that you should put brackets around it. Like whatever operation happens, that needs to be done first before you divide. So angle F, which is the same thing as angle E, is simply, this is 150, no, sorry, 130 divided by 2, which is 65. Okay, so you've in fact found, you now know all three angles. So it's either you know one of the congruent angles, or you know the one that isn't congruent, which allows you to find the other two. Okay. Hope that makes sense. That should be a blast from the past, right? And then this one, all angles are, I will just do this. All angles are congruent. All sides are congruent. That looks pretty bad there. It bled through from the other side. And so that's just your classic, all sides are the same. Therefore, every single angle across those sides has to be the same. So if you go A, B, C, right? Angle A, which equals angle B, which equals angle C, is just 180 divided by 3. You're just going to split that in 3 equal parts. That is 60 degrees. It doesn't matter how big the triangles or how small the triangle is, 60 always. Okay? That's important to remember. Next, we've got our convex versus concave that I need to review. And just, what's the difference? How do you recognize concave? It's caving in. You have right here, sorry, not there. My bad, my bad. If you focus inside the shape, you have this reflex angle. That's how you would know something is concave. No, you want to go no reflex here. So I'm becoming pretty convex. My reflex are leaving me as I get older. All right, regular polygons. That word regular means a lot for us in math. Regular, it tells you two things. All sides are congruent and all angles are congruent. So immediately you know, oh, regular, got it. Everything is the same. All sides measure the same, all angles measure the same. Irregular, however, irregular means that some, right, some angles may be congruent, some sides may be congruent. So in essence, if all angles are the same except for one, immediately that shape becomes irregular. Okay, so that's the main thing here. And so I have it actually, I break it down into two categories, like you see the shapes here. Let me just, right? So you've got your equilateral triangle and your square. Okay, equilateral triangle, and this is your square. So these are definitely congruent. So if you think about it, the markings tell me that, and a square has 90s all around, right? 90, 90, 90. And an equilateral 60, 60, 60, and all sides are the same. However, an isosceles, this one, isosceles triangle, two sides are the same, but it's irregular because we need all three to be the same, right? This is, what kind of triangle is this? This is scalene, right? Scalene triangle. This is just whatever, and this is a rectangle. For a rectangle, watch this, all angles are the same, correct? For a rectangle, all angles are 90. So the all angles checkbox is good, but not the sides, okay? So I would say angles are congruent, that checkbox is good, but sides congruent, that is a no, right? That fails that, so it goes into the irregular category. a lot of review, I know, but I'm really honing in on the things you need to remember for what's coming up. Okay. Next. Page 11. All polygons have interior and exterior angles. Every single one. Interior and exterior angles are supplementary, sum of 180 degrees. So let me show you what I mean by that. So I'm going to use a blue pen and a red pen. You don't have to, but I will just focus in on one corner, one vertex. So if we focus in on this point right here, you've got inside here, inside the shape, we have an interior angle. Okay. And at every interior angle, there's an exterior angle to it. So what you do, how do you find the exterior angle, Mr. Dirks? You choose. So you go to the point and you either pick this line that comes to that point or you pick the other line. It doesn't matter. I'm going to pick this one. And I'm going to like kind of travel along to the point, but I'm going to extend it. It's as if I'm grabbing a ruler and I'm just extending that side that I was traveling along. Okay, that's how you come up with your, watch this, exterior angle. Okay. So this happens at every single intersection. Can you see, would it make sense to you if I told you they add up to 180, that they're supplementary right there? Yeah, because they're along a straight line. So there you go. Now you know that that's true. I will tell you this here. It might come up again, but this has how many sides? 1, 2, 3, 4, 5. 5 sides, 5 interior angles, 5 exterior angles. That is something that you need to, that pattern is always there. Triangle, 3 sides, it will have 3 interior, 3 exterior. Okay. And this is important here. This is always true. Sum of exterior angles is always 360 degrees. Always. Regardless if irregular or regular. Regardless of the number of sides. Right? So think about, I don't have my iPad ready to go, but if you were to add up the exterior angles of any shape, it would always add up to 360. It's an interesting concept. If you think of a rectangle, you don't have to write this down if you don't want to, but it has a 90 here, a 90 there, a 90 there, a 90 there. So those are your interior angles, right? At every corner, you could extend it. You have your 90 there. Let's extend this one. And then I'm traveling here. And then I'm traveling here. So what do you have? 90, 90, 90. So that adds up to 360, right? If you look at a triangle, let's look at our equilateral triangle where every single one of them is 60, 60, 60, and 60, right? Then you travel. If I ask you to label all of the exterior, all you do is you travel along, extend it. You got your, what is this here? 120, right? You travel down, extend it. You've got 120. You travel here. You got 120. 120 times 3, 360, right? So, sorry, 10. So it's always 360. The sum of exterior is always 360. At the same time, if you know the interior angle of a shape, you will automatically know the exterior. right? You just subtract it from 180 to get the exterior. On the other side, conversely, if you know the exterior, you can automatically find the interior, right? You would just subtract it from 180 because you know they add up to 180. So if I give you one, you have the other, okay? And that's what I'm going to add here. Exterior plus interior always adds up to 180, right? So you can use this formula to figure out the other one. All right, let's keep going. These formulas have to be on your formula sheet. So make sure you add that. You can make it very compact, right? You don't need to expand on it, but always remember that n refers to the number of sides of that polygon. So the sum, right? The sum of interior angles is denoted by the letter S. So the sum of the number of sides would be n minus 2 times 180. The interior angle, right? Measure each interior angle. This is the formula. Can I just do this here? If you look at that one right there, it appears again here. But what's the difference in this case? You're dividing by the number of sides. Whereas here, it's all the interior angles added up. Here, it's just each interior angle that they're interested in. So you'd have to divide it by the number of sides. Central angle, measure of each, typo. This is supposed to say central. Good thing I got it. Yeah. C stands for central angle. I will give you a diagram where I show you where it is. So for now, just follow. Exterior angle is 360 divided by n. This goes back to what I just told you, that all exterior angles add up to 360. So if you divide it by the number of sides, then you get the measure of just one, just each exterior angle. And then the last one is the number of diagonals that can be drawn. And I will also show you that in the one of the polygons that we're going to look at. I just want you to focus on ICE here, ICE, right? ICE. What does that? Every single one of them only work for. That's you. Regular, regular, regular. So for ICE to work out, the shape needs to be a regular shape, or else the formula doesn't work. Okay. Okay. You remember f of x, right? F of x, you put something in for x and then you solve what's on the right side. It's the same thing. It's like sum in terms of the number of sides. You plug in n on the other side, whatever n happens to be, and then you just solve, okay? So don't let that scare you too much. Let's keep going. Page 12. Okay. I know this is a very cheesy acronym, psyched. I'm telling my students to think that you're psyched about this unit. But anyways, the sum, interior, central, exterior, and diagonals, right? That's like the acronym for the formulas. But we will label the interior, the central, and the exterior on this, okay? So we have, first and foremost, when you count sides, because there are going to be many, I have a software, I can make it like 23-sided polygon. Don't do it, Mr. Dirksen, don't do it, right? So 1, 2, 3, 4, 5. Like, check off where you start counting, because a lot of students are even off by 1, and it's very frustrating, okay? So I counted, and n is 5 right away. That means that I have 5 sides, 5 interior, 5 exterior. Okay, so I'm just asking you to do one. Let's do the interior angle. I used blue before. So just pick any corner. I'm going to pick this one. And I'm going to make sure that this angle formed between these two sides is that interior angle that I'm after. Then grab, you can just use pencil, that's fine. Travel along one of these sides. So if I travel along the bottom here, go to the corner and then keep going in that same trajectory. And that's your exterior angle there. It's almost like created by that imaginary line here and one of the sides. Common mistake is this. You ready for it? That's the most common mistake. You have to travel along one of the sides, right? Either here or here. But this is going like out to space here, right? So you don't do that one, okay? I'm gonna be picky with that. The next is your central angle. I don't have a third color, so I'm just gonna go. You kind of find the center, obviously, central, right? And then just go to one vertex, and then go right to the one next to it. Doesn't matter if it had been here or here, but this angle right there is a central angle. You can imagine, right? What if you were at the center and you turned all the way around, how many degrees would you go around? 360, right? So the formula for a central angle is 360 divided by one of the sides, right? So you're basically splitting, you're slicing the pizza, right? Think of, you're saying if it's 360 all around, then one of these angles, one of the central angles would be 360 divided by the number of sides, okay? So ice is done, okay? Next, let's go to this one. Oh, we're supposed to calculate. Let's back up. Calculate all of these. So sum of 5, right? A 5-sided polygon calls for 5 minus 2 times 180 degrees, which is really 3 times 180. Just 540, right? I'm allowing you to do the choo-choo train, right? Like if it's just like a linear, there's no cross multiplying and dividing, you're okay saying this is the same as that, which is the same as that. You're kind of solving it, right? Interior angle of a 5-sided would be 5 minus 2. It's exactly the same as above. However, a lot of students miss it, like they don't divide by 5. Okay, so I'm going to cheat here. I know that the top is 540, correct? I don't need to redo that. I'm just now going to divide it by 5. And that's 108. 108 degrees. Make sure you have your degree symbol, right? You will get decimals at times. This time it's just a whole number. If it's decimals, 2 decimals, okay? Central of a 5-sided would be, the formula calls for 360 divided by n, okay? So 360 divided by n is 72 degrees. And you can always know that the exterior angle is exactly the same. It calls for the exact same formula. So your answer will be the same. And the last one is the number of diagonals. That one is not very common, but it does show up. So that calls for n minus 3. Sorry, I actually have to check that one. I always forget. Is it n times n minus 3? Sorry. So let's do it right. N times n minus 3 divided by 2. So that would be 5 times 2 divided by 2. Can I cancel these? Yep. So that's just 5. Okay. 5 diagonals, not degrees. I think it's going to be too messy if you do it. So maybe just watch what I'm gonna show you what we just found. If you were to pick any corner in this particular polygon, this is one diagonal. You can't connect here because they're already connected. Two diagonals, right? So keep count. I'm going to go to the next corner. One diagonal, two diagonals. So that's 4, right? And there's one more. You see it? Oops, sorry. So there are 5 diagonals here. And the more sides you have, the crazier this, like the bigger this number is. So I would never ask you to actually draw it because it's just very time consuming, right? But it can be drawn, okay? All right. So I did all of them, right? Psych, yeah, okay. I will let you do this one. I think at this point, I'm doing it quickly. Okay, so central. I want you to get this right. I don't want you to make a mistake. Then you pick any corner. I pick this one. That's your interior. And exterior, you just right? You just travel out. Exterior, there's your. How many sides does this thing have? Count, right? So check mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is equal to 11. Okay. So the sum of 11 would be 11 minus 2 times 180. I'll just give you the answer. That's 1620. 1620 degrees. The interior angle of an 11-sided, I'm going to cheat. I'm just going to take it's not really cheating, right? I'm just going to take my previous answer divided by 11, right? Because it's really just the sum divided by 11 equally. And that would be, and here's your first decimal. Central of an 11-sided shape is 360 divided by 11. There's your other decimal. Exterior. Oh, I want to see if you knew. Would you be able to figure out the exterior angle a different way than using the formula, like one of the psych formulas? I talked about it. What do we know about interior and exterior angle? What do they add up to? 180. So here you could say E is 180 minus I, right? Which is 180 minus, what do you think it's going to be? Central and exterior are the same, correct? We're expecting our answer to be 3273. But let's keep going. So my interior angle is 147.27, and that, lo and behold, adds up to that. Okay? Or how about we do or? Because some of you are going to look at this down the road and you'll be like, huh? Right? What happened there? Or I actually use that formula, right? 360 divided by 11, 3273 still. Number of diagonals. Diagonals is n times, I forgot again. Is it n minus 3 or minus 2? Minus 3. It's n minus 3. So 11 minus 3 divided by 2, which is 11 times 8 divided by 2. Let's do some mental math there. When it's just multiplying and dividing, right, I would go 8 divided by 2 is 4. 4 times 11, 44. 44 what? Degrees or it's diagonals, right? Diagonals. There we go. Not degrees. The 30-sided shape, I'm not, I think, I'm going to leave this. If you want to do this for homework, you go right ahead. It's a 30-sided shape, so no diagram, but n is equal to 30. It's almost easier than the other one because you don't even need to count the number of sides. but I think you got it at this point. I just add more examples than what I will need, just in case. So what if you got something like this? I'm not going to tell you what the central is, what not. I'm just going to say, hey, this diagram solve for ABC. Right? So I expect you to know what you need to do at this point. So A is what? That's my interior angle. C is what? That's my exterior angle. B is what? Not quite. I tricked you there. See that vertex in between? Ah, right. So you gotta watch out. So B is two central angles, correct? Right? Like watch this. This is a central angle here. So B is 2C. Tell that to your English teacher, right? B is really 2C. And then you go from there. So to find angle A, right? Angle A, use the angle symbol, right? I just need to take n minus 2 divided by n, correct? So I'm going to count 1, 2, 3, 4, 5, 6, 13, 14, 15. I count 15. N is equal to 15. Establish that right away. And so this would be 15 minus 2 times 180 degrees divided by 15. Okay, so that would be 156 degrees. So A is, we answered A. We knew that we had to use the interior angle formula to get that. Okay, I'm going to go with angle C. I will just go 180. I like this one way more than actually using the formula. Minus angle A, correct? Would you agree with that? I might be rushing. I don't want to rush to something that you don't understand, right? I want you to understand that this angle is the same. Like you could place A right here, right? Which is also an interior angle, but these two are supplementary, right? So it's angle C is 180 minus 156, and that is 24 degrees. Each exterior angle is 24. Let's do a quick check here. What do the exterior angles add up to? 360, right? So 24 times how many exterior angles are there? 15. That adds up, right? So you should be able to double check whether or not you're getting that right. Hey, if I put my calculator on there, it does a beautiful yellow. Yeah, just keep my calculator on the screen. Yeah. Okay, B is equal to, okay, I need to watch out here. The C, that wasn't a good choice of letters. Two central angles. How is that? Because otherwise you're going to think it happens to be the same though. Remember, central and exterior, they usually are the same. So I don't know. So angle C is 2 times 24, which is 48 degrees. Watch out for if it's 3, maybe it's 3 central angles. You decide. You have to watch carefully for what's happening here. Why will I do this? I will say this: central angle equals the exterior angle. Okay, that's the reasoning for me just using that 24. I just went ahead and used it. Okay, polygons. And okay, yeah, I'm going to finish this. When so this is just basic. I'm expecting you by tomorrow already to know how to work these, to know how to find interior, you know where the exterior is, all of that. So just make sure you understand how that works. I'm going to quickly fill this in partially, and I want you to do the rest for homework. So prefixes, let's talk about them. So triangle, quadrilateral, pentagon, hexa, hepta. I expect you to know these. Octa, nona, deca, dodeca. So number of sides, 3, go ahead, 3, 4, 5, 6, 7, 8, 9, 10, 12. There's I don't, as far as I know, there's no particular name for the 11th. I'm sure there is, but these are the ones that are going to come up here and there, and I need you to know dodeca. Okay, that's a 12-sided polygon. Okay, and so basically at the top here, I'm going to ask you to just write down homework, fill in. Okay, and I want you to pay attention to some of the patterns you will observe. So number of sides is n, right? Sum of interior, you will just use this formula for S. Interior angle is I. This is exterior, and this is your central. And you're like, what about diagonals? We're not going to add that here in this table. So you should be seeing some patterns as you fill this in, okay? So that's just so you know. It will be helpful because some of them you'll memorize. You'll just know a pentagon, the sum is this, 540 every time. So I mean, I don't want to spend class time on this, so you go ahead and figure this out, okay? Let's keep going. Page 14. Working backwards, so you have to use algebra here. And so you're doing backwards operations. You'll be given the sum, the exterior angle, the interior angle. You will be given that. Now you have to figure out how many sides are there. And I don't want you to guess and check if you want to get full marks on this. Because you can guess. Students like just try a bunch of numbers like, oh yeah, it's 15, right? I want you to show me the work here. Okay, so here we go. Start with the appropriate formula, then isolate for n. That's basically the game plan. So the sum of interior angles of a polygon is this. So we know that this is S. Okay? Determine the number of sides. So we know that the sum is n minus 2 times 180. And I might be doing this a little differently than what you're used to, but you'll get the hang of it. Okay. Let me actually change this. I will use a red pen, right, to just plug in. I'm plugging this in on the left side, right, as 30, 60, right? I don't know the number of sides, but I'm going to figure it out. What's my next move here? By the way, there are many options. You could distribute, right? Some of you are thinking distribute. Just multiply the 180 times n and multiply the 180 times negative 2. You can do that if you want. I would rather do this. I will divide both sides by 180 degrees to cancel them out. It saves you from having to FOIL it, right? You remember that? FOIL? Right, so you cancel that on the right side, and on this side you come up with a number, right? So you're going to go 3060 divided by 180. That's 17, right? So this turns out to be 17, and on the other side, it's just n minus 2. We can get rid of the brackets now because the 180 that was multiplying is now gone. And here, I sometimes bring things over. Some of you are going to say, no, I'm going to add 2 to both sides. And so I end up with 19 on the left side and n on the right. It's okay to state an answer like this. Okay? And you should be comfortable with the number being on the left and the variable on the right. You've successfully isolated the variable. Okay? So you're good. So 19 sides, right? 19 sides. How about a regular polygon? Next here. A regular polygon has exterior angles of this. So they're basically giving you the exterior angle. Determine the number of sides algebraically. So you go to your formulas, your study sheet, right? Oh, exterior is right here. Exterior angle is simply 360 divided by n. You're going to love this one. This one is actually not too bad. Right? And then you plug this in for E. So you're substituting that in. So that's 11.25 degrees is equal to 360 degrees over n. What would you do now? What does this look like? Cross multiplying, dividing, right? So I'm going to do that little cheat here. It's not really a cheat. The 1 has always been there. We're just now it's visible, right? So you cross multiply and you divide. So 360 times 1, if you'd like, divided by 1125. I want to see this step here. Some of you know what I'm talking about. If you saw work on your test, this is what I mean, that intermediate step, okay? It takes you maybe 5 seconds to do that. So 360 divided by 1125, 32, okay? 32 sides. And you're done. So some of them are easier, some of them are a bit more challenging. And this is the hardest one that you're going to see here. One of the harder ones. So we went intermediate, and now the harder one. So I'll read it. A regular polygon, which is important. Regular means all angles are the same, all sides are the same. We have interior angle is 171. That's I. Calculate the number of sides. 2 methods. I will show you 2 methods here. The long one and the short one. Okay, so method 1. You simply use this formula. I'm just going to leave the 180 out, not in brackets, like that. Right? N minus 2 times 180 over n. You substitute in what you know. Okay, so 171 goes in there. And then it's n minus 2 times 180 over n. Let me just zoom back down like that. So I always like to, when I see something in the denominator on one side, I like to get rid of that first. Okay? So avoid the temptation of foiling this out. So what I do is this. I'll go times n. I'll go to the other side and multiply that by n as well. And now I can cancel these n's here. And on this side, what is 171 times n? 171n, right? Just like that. N minus 2 times 180. At this point, you should know what to do. Doesn't this look like the first example we did? Yeah. So, hold on. I want to show you the easiest way of doing this. Why do it the hard way? You can divide both sides, but you need to be careful with decimals. And I think there's going to be a problem with that down the road. So what I'm going to do is this. I'm actually going to FOIL this one. Ready? Yay, right? So such good memories. So 180 times n, 180 times negative 2 is negative 360. It can be done the way I did the first one, divide both sides by 180, but then you will come into decimals. Okay. And what am I going to do now here at this point? What do you think? My goal is to isolate n, correct? I'll bring all the n's to one side, right? Like that's my goal. So to me, it's easier to bring this over to this side. So some of you prefer this method, so I'm going to go ahead and do that. Okay, you're subtracting 180 from both sides. What's 171 minus 180? Negative 9n, right? You're subtracting. This cancels out, so you're left with negative 360 on the other side, which is, it's a good thing that you have negatives on both sides because it will straighten itself out, right? I'm going to go divided by negative 9, divided by negative 9. Cancel these out, and you're left with 40. Remember, it's sides, right? When you're solving for n, you're solving for the number of sides. Method 2, which is my favorite because it's just easier. It's all about making it easier, right? But I need you to understand that, right, it can be done this way, it can be done the other way. Ready for it? Yeah. So what I'm going to do is this, folks. I'm going to say that if I know the interior angle, then I can also find the exterior. Remember I told you that? If you know the interior, you can find the exterior. How so, Mr. Erickson? Well, remember they were supplementary, right? So I'm going to go minus 171. So I'm going to go 180 minus the interior angle, and that gives me an angle of 9 degrees. So the 171 came in here. Okay? And now I'm going to use this one. Now that I have my exterior angle, I will use this formula. Right? I know that this is 9. So I'm going to go 9 is equal to 360 over n. And what's happening now? Proportions, which is cross multiply and divide, right? Yeah, it's proportional reasoning. Yeah, exactly. So I put the 1 there just to help me determine that I have to multiply and then divide. So that's 360 times 1 divided by 9. Isn't that exactly the same what's happening here in a sense, right? Yeah. So that is 40. I'm just going to do another line because I have room. 40 n is equal to 40 sides. So, I mean, some of you might say, like, that's easier. I find the left easier, then go with it, right? Like, it's not, I'm not going to force you to use one over the other as long as you know how to do it, okay? I do expect you to find the exterior angle in 2 ways, like subtracting, right? Or using the formula. That I do expect you to know how to do. Okay, so this is backwards, right? It could also be done with a diagonal formula, right? That one will be a bit of a tougher cookie, right? But I think I've shown you enough for you to know what needs to happen. Okay. If you, for whatever reason, over here, where was it? Over here, if you chose to divide both by 180, I'm just going to give you a heads up there. So 171 divided by 180. Okay, in this case, it's a finite decimal, so you would have been fine. You would have ended up with 0.95 n, and then just keep going. It would have worked out. All right, next. This is all you try. Let me just see here. So I'm going to walk you through a little bit before you start, because I feel like you will have some questions. And I just want to see where I'm going to lead you after this, because I don't want you to forget about what we've been doing so far. So this page, plus in the workbook, I'm just going to flip through the workbook real quick. There are some that are going to start, page 20 to 21. In the workbook. Try those, and I'll show you real quick what they look like. So it looks like this. Let's see. The first thing I need you to do is, when there are 3-letter notations for an angle, go find it, but then give it a letter. Okay? I don't know if you came across that already, but DGF, right? So we're talking this one right here. Call it A or something like that, right? So now you know that's lowercase a. And then do that first, identify where they are, and then go back and try to solve. And we've done parallelograms, right? This is an isosceles triangle here. So you should be able to figure things out. There are straight lines. All of those things are happening at the same time, okay? So I want you to try that, as well as the stuff we're doing now, polygons, because tomorrow we're going to step it up a notch, okay? So what's happening tomorrow, Mr. Dixon? This kind of stuff, where there's going to be shapes inside the polygons. So that's when what you're learning today, that's where it's going to come in handy, okay? So this is backwards. I will let you do those ones. I will post a key to this as well. But what about this one? Right? You're like, what's going on there? Look at the bottom of page 15, this one here. We've done variable questions. What would all these angles, how would we relate them? Do we know what they should add up to if I were to add up all these angles? There's a way to find out. What do you start with when you try to find out what it adds up to? You count the number of sides, okay? So you're like, this doesn't look regular at all. The sum of interior angles, that formula is not affected by whether or not it's regular. Okay, so you need to figure out, okay, step number 1, how many sides? Step number 2, what is the sum? And then step number 3, solve for x. Okay, so now some of your wheels are spinning, right? You're like, okay, yeah. Okay, so when you do polygons, guys, think of, number of sides. Oh, if I have the number of sides, I can do the psyched, right? I'm so psyched to do the homework. That's what you're thinking, right? you can do that because all of those formulas ask for n, right? They all do. And then think of what else can I do? What else can I solve for? Okay. And so I'm going to leave that up to you. So actually, we have a little bit of time for you to do the work. So I'll give you this. I noticed that there's a bit of a problem here. I haven't given you enough of the polygons like formulas. You know what we just did here? Like this kind of stuff. This I expect you to know how to do by tomorrow already. Like telling me where the angles are, calculating this. And so there's one that you can try right here, right, on your own. So I agree, I haven't done a whole lot. And then this table, if you fill in this table, you're going to use those formulas over and over. So you are practicing that, okay? So if you want to do the table now, or if you want to do this where you work backwards, it's up to you. Use the time wisely. Go ahead. That's all for today, okay?